Usually when you write a script or compile a piece of code, there's this expectation of absolute line-by-line determinism. Like, you input your data, the function applies a transformation, and you can see exactly how the output was generated.
Yeah, it's clean. You get a traceable log file.
Exactly.
If something breaks, you just follow the stack trace, you find the exact line, and you fix it. It's an open book.
But I mean, as a data scientist working in the tech space today, you know that era is practically over.
Oh, completely.
You step into this current landscape of massive language models and agentic workflows, and that traceable log file just vanishes.
Yeah, it's gone.
We are looking at a diagnostic and operational landscape that's becoming incredibly murky. The models are, they're beginning to obscure their own internal logic.
Which is exactly why we're pulling together this deep dive for you today.
Yeah.
Because the AI and machine learning landscape is moving at just a breakneck pace. And our mission here is to sift through the noise. We want to deliver a highly concentrated dose of the latest advancements, specifically curated for what you are building and optimizing right now.
And we have a massive stack of sources to pull from today.
We really do.
We're looking at the 2026 Stanford AI Index, some really cutting-edge research out of Hugging Face, Archive, and LMSYS, plus the latest tech updates from Microsoft Research, DeepMind, Anthropic, Meta, and Pandaily.
It's a lot of ground to cover.
It is. And the clear through line connecting all of this, our hook for today, is that we are officially moving past the era of simply building bigger models.
Right.
We're entering this new era defined by deep architectural efficiency, agentic workflows, and models that actually possess an internal mental workspace.
Yeah, and before an AI can execute complex reasoning or maintain any kind of mental workspace, the underlying architecture has to solve some fundamental physics problems.
Right, the hardware side.
Exactly. Specifically, the massive compute and memory bottlenecks associated with long contexts and multimodal inputs. I mean, the math just doesn't scale if you keep using the same brute force methods.
So let's get right under the hood with what's happening in architectural efficiency and disaggregation. Looking at the LMSYS and Hugging Face research, the first major breakthrough is this mechanism called his sparse.
Yeah, his sparse is fascinating.
If you're working with large language models, you already know that self-attention is a massive bottleneck when you scale to long contexts. The compute and I/O costs, they scale quadratically.
Right.
If you double the context, the compute cost quadruples.
Which is just punishing on your hardware. So his sparse attacks that quadratic scaling problem by using hierarchical memory.
Okay, how does that work in practice?
Well, to understand why this matters, you have to look at how it actually handles the data.
Yeah.
Instead of keeping every single token active in the GPU as high-speed memory.
Which is what we usually do.
Right, exactly. His sparse creates a multi-tiered hierarchy. It identifies which tokens are critical for the immediate attention head and keeps those in the fastest memory layer.
Okay.
And then the older, less relevant tokens are aggressively compressed and offloaded to cheaper, slower memory tiers.
Oh, I see. So it's actively sorting them.
Exactly.
Wow.
It fundamentally bypasses that quadratic cost by ensuring the processor is only doing the heavy mathematical lifting on a highly curated subset of the context window.
I mean, that is a game changer for document retrieval and long horizon tasks.
Absolutely.
Because you're making massive context windows computationally viable without just burning through your entire GPU cluster.
Yeah, it saves so much compute.
But there's also a major shift happening in how vision language models, or VLMs, are physically processed, right?
Oh, yes. SGLang just introduced something called EPD disaggregation.
EPD. And that stands for encoder prefill decode, right?
Yes, encoder prefill decode. Historically, VLMs processed everything in a heavily coupled pipeline. You'd feed an image and text into the model, and a single monolithic architecture would try to crunch the visual matrices and the linguistic tokens simultaneously.
I like to think of this in terms of like a high-end restaurant kitchen.
Okay, I like where this is going.
Before EPD, you had one master chef trying to chop the vegetables, sear the steak, and plate the dessert at the exact same time on the exact same counter.
Which is chaotic.
Right. It's chaotic and inefficient. But EPD is like having a dedicated sous chef whose only job is prepping the visual ingredients.
Yes.
They chop the vegetables and hand them off. The head chef, the language model, never has to touch a knife. They just take the prepped ingredients and focus entirely on the complex cooking process.
That perfectly illustrates the separation of workloads. I mean, the vision encoding requires a completely different type of matrix multiplication. multiplication than the language decoding. By isolating those workloads, you can process them on the specific hardware best suited for that mathematical operation asynchronously.
So they aren't waiting on each other.
Exactly. The language model isn't waiting idly for the vision encoder to finish. They are both operating at maximum utilization.
Wow. And speaking of optimizing hardware, the third major advance here is FreeToken,
Yes.
which is an edge-native mixture of experts serving system. It dynamically maps computation and model state onto heterogeneous local hardware.
Right.
So basically, you can run massive open-weight models on a personal machine without needing a server farm.
And it achieves this through a mechanism called bandwidth adaptive execution.
Which sounds very complicated.
It sounds complicated, but, well, in a traditional mixture of experts model, you have a router network that decides which expert subnetworks need to process the specific token, right?
Yeah.
The challenge is moving that data to the right expert at the right time. When you try to do this on local heterogeneous hardware, like mixing a CPU, a consumer GPU, and unified memory, your biggest bottleneck isn't the compute.
It's the data transfer.
Exactly. It's the data transfer bandwidth between those physical components.
Because the PCIe bus just gets completely saturated trying to shuttle all those weights around.
Yeah, that PCIe saturation is the exact problem bandwidth adaptive execution solves. It acts as a highly intelligent traffic controller. It constantly monitors the real-time bandwidth limits of your hardware.
So it knows when it's about to jam up.
Right. If it detects that the GPU bus is about to get clogged, it doesn't just queue the data and cause a massive latency spike. It dynamically reroutes the computation.
Oh, wow.
Maybe sending a less critical operation to the CPU or dynamically quantizing the weights to reduce the payload size. It prevents the bottleneck before it ever happens through real-time load balancing right at the silicon level.
That is incredible. But, all this optimization at the edge, like running these massive models locally, it's heavily driven by what's happening at the macro level with hardware supply chains.
Oh, absolutely.
The geopolitical and economic realities of AI hardware are forcing an incredible amount of innovation, leading to a massive global hardware pivot, particularly in the Asian market.
Yeah, the reports from Pandaily highlight a massive structural shift here. Companies like DeepSeek and ZippoAI are no longer just building models and renting cloud space.
Right.
They're developing their own custom inference chips to completely cut their dependency on traditional GPU providers.
I mean, the narrative around the China AI stack has fundamentally flipped. For years, the conversation was entirely about them trying to catch up to Western hardware.
Yeah, catching up was the buzzword.
Exactly. But now they're setting the pace in efficiency. Huawei's cluster plus superpod architecture is a prime example of this. When you combine that physical infrastructure with their open source Canon framework, they've essentially created a complete end-to-end ecosystem alternative to the CUDA monopoly.
And for anyone heavily involved in model training, you know how deeply entrenched TUA is in the machine learning workflow.
It's everywhere.
Right. It's a proprietary software layer that allows frameworks like PyTorch to talk directly to NVIDIA GPUs. By pushing the Canon framework, Huawei is compiling graph operations directly for their Ascend chips. They are bypassing the need for CUDA entirely.
That's a huge shift.
It is. And the models they are deploying on this alternative infrastructure are staggering. DeepSeek V4 Pro just dropped. It is a 1.6 trillion parameter mixture of experts model.
And it's running with FP8 and FP4 weights.
Which is a crucial detail.
Yeah, explain the FP4 part, because that's significant.
So FD4 quantization reduces the precision of the model's weights down to just 4 bits.
Okay.
You lose a tiny bit of mathematical precision, but you drastically slash the memory bandwidth required to serve the model.
So you can run it on way less hardware.
Exactly. It allows them to run a 1.6 trillion parameter model on a fraction of the hardware you'd normally need.
That's wild. But while the model capabilities and hardware efficiencies are exploding, the business models are shifting violently.
They really are.
ByteDance and Alibaba are actually sunsetting their consumer AI agents. Features like Dubao and Quinn's consumer applications are being pulled back. So I have to push back a little here.
Okay, sure.
If these massive players are sunsetting consumer agents because the economics don't work, does that mean the whole agentic AI hype is just a bubble?
Well, it's not a bubble, but it is a harsh reality check on product market fit.
Okay, how so?
Agentic AI is graduating from, consumer novelty into enterprise and rigorous research environments. The consumer space is plagued by regulatory compliance issues and terrible monetization economics.
Yeah, that makes sense.
I mean, people generally don't want to pay a premium monthly subscription for a chatbot that plans a hypothetical vacation.
Right, exactly.
ByteDance recognized this and pivoted immediately to highly specialized enterprise tools.
Like CDream 5.0 Pro,
Yes.
which handles complex infographic generation and UI mockups. And then there's DeepInNet, which is an enterprise AI all-in-one machine specifically tailored for the real estate sector.
Yeah, and that's the core realization here. To succeed in the enterprise, agents don't need a fun, conversational personality. They need better structural frameworks, reliable long-term memory, and tangible, executable skills.
Which brings us directly to the memory problem.
Exactly.
If you want an agent to act autonomously over days or weeks, say, managing a continuous CI/CD pipeline or researching a complex data set, it can forget the context of what it did yesterday.
Right, and Microsoft Research has been tackling this head-on with a system called Memora.
Memora?
Yeah, it uses a harmonic memory representation. Instead of just dumping everything into a massive vector database and hoping for the best during retrieval, Memora balances abstraction and specificity.
How does it do that?
It maintains a hierarchy of memories. So it continuously condenses older events into broad semantic concepts while keeping highly recent events as detailed episodic memories.
Oh, that's clever.
Yeah, this way, the agent doesn't have to constantly reload its entire context window. It pulls the broad abstraction of yesterday's work and the highly specific details of, say, the last 5 minutes.
And the open source community is also pushing this forward with MemZero, right?
Yeah.
It is a scalable long-term graph memory system. By using graph architecture, it maps the relationships between entities rather than just their semantic similarity.
Which is much more efficient.
Yeah, it extracts, consolidates, and retrieves information far more efficiently because it actually understands how different pieces of data are connected. But, I mean, memory is only half the puzzle. An agent also needs to know how to actually execute actions based on that memory.
Right, and this is where a framework called SkillOpt comes in. And it introduces a completely new paradigm for training agents.
Okay, tell me about SkillOpt.
So historically, you either gave an agent a massive prompt with step-by-step instructions, or you fine-tuned the actual model weights, which is expensive and often degrades the model's general knowledge. SkillOpt turns agent skills into trainable parameters without changing the core model weights.
Wait, how does it manage to train skills without touching the underlying weights? That sounds counterintuitive.
Think of it like a lightweight executive policy layer that sits on top of the base model.
Okay.
It functions as a strategy optimizer. It allows the agent to essentially self-evolve its own skills based on environmental feedback. The agent tries an action in a simulated environment, gets a reward or penalty, and SkillOpt updates this lightweight parameter layer to refine the strategy.
Wow.
Yeah, it gives you evolving skills with zero deployment inference overhead because the heavy base model remains completely untouched.
Okay, but to train those skills, these agents need realistic playgrounds, not just static text prompts.
Exactly.
So Microsoft introduced Echoverse, which trains computer use agents in deep, evolving, realistic digital environments. They also released Orchard, which is an open framework for scalable agentic AI. It lets researchers reuse infrastructure and get surprisingly strong performance even from smaller models just by giving them better environmental grounding.
Yeah, it's impressive. But, to ground all this hype, we really have to look at the ASI bench study that was recently published on Arcade.
Oh, yeah. That was a severe reality check for the entire industry.
It really was. They evaluated 18 state-of-the-art agent models on end-to-end scientific research tasks.
And the results were definitely sobering. When the agents were given full human methodological guidance, basically step-by-step instructions on how to conduct the experiment, they scored a 50.91.
Right.
But when the agents had to determine the scientific method themselves from scratch, the score plummeted to a dismal 26.62.
Yeah. It proves that current agentic systems remain heavily dependent on human guidance.
Yeah.
I mean, they can execute flawlessly, but they struggle to independently formulate a path through the unknown.
It's like we have built a brilliant self-driving car that can execute perfect turns, merge onto highways, navigate traffic without a scratch.
Right.
But the second you stop giving it turn-by-turn directions and just say, figure out the most efficient way to supply pizza to the entire city, it just parks on the sidewalk.
That is a perfect analogy.
It fails at the core methodology. They possess incredible execution capabilities, but they lack true autonomous reasoning.
Yeah. And if we want agents to bridge that gap from a score of 26.62 to true autonomy, we have to understand how they are thinking internally,
Right.
especially when they tackle hard logic and complex mathematics. We really have to look inside the black box.
And the interpretability research coming out right now is fascinating. Like, Anthropic just published a paper revealing an emergent phenomenon inside Claude that they are calling a global workspace.
Yeah, this is a massive conceptual leap. In cognitive science, the global workspace theory applies to human consciousness. It is the idea that our brains have a central workspace where different unconscious processes broadcast information to be consciously integrated. Seeing a localized version of this emerge in a large language model is profound.
Break down how this global workspace actually functions inside a neural network, because it's not just a simple scratch pad, is it?
No, it's far more complex. When you ask the model a highly complex question, the data passes through dozens of layers. The global workspace acts as a bottleneck layer, where the different attention heads must essentially broadcast their findings, debate, and force a consensus.
Wow.
It's Hell's holding internal thoughts, weighing probabilities, and resolving mathematical conflicts in a hidden state that never actually appears in the final text you read on your screen.
I picture it like a tense corporate board meeting.
Oh, what
You have all these different department heads, the layers of the network, arguing over a budget in a closed-door room. They debate, they compromise, they scrap bad ideas.
Yeah.
And the final press release that goes out to the public, which is the generated output token, is just the agreed-upon number. It completely hides the chaotic negotiation and alternative thoughts that led to it.
That's exactly what's happening.
But that raises a terrifying question for governance. If the model is having internal thoughts that it doesn't output, how do you audit that?
Yeah.
Are we entering an era where we need AI psychologists to interpret the model's internal workspace just to ensure it's safe?
Well, we are definitely moving from auditing outputs to auditing latent space states.
Right.
If an agent calculates a highly dangerous strategy, maybe a novel zero-day exploit, but chooses not to output it because of safety guardrails, you still need to know that the calculation occurred.
Exactly.
The capability is there.
And their internal calculations are reaching entirely new levels of sophistication. I mean, an unreleased research version of Claude recently made major strides on the Riemann hypothesis, which is one of the most famous unsolved problems in mathematics.
Yeah. The model improved a long-standing lower bound for the fraction of zeros of the Riemann zeta function, from 41.6% to 67.2%.
Okay, that's a huge jump.
Yeah, it's massive.
Yeah.
And it's important to understand what this means. This isn't just pattern matching or regurgitating code from a GitHub repository.
Right.
The model had to synthesize novel proofs. It's an AI system contributing original deductive logic to higher-order mathematics.
That is wild. I mean, we've gone from the deepest levels of chip architecture to the internal hidden thoughts of a language model. Let's look at how these advances are physically interacting with the real world in novel applied machine learning use cases.
Yes.
Because the application layer is where we see the immediate societal return on these architectural investments.
Right. Let's start with weather and climate modeling, which has seen a massive leap in accuracy thanks to these new architectures. DeepMind released WeatherNext, which has achieved unprecedented breakthroughs in cyclone forecasting.
And Microsoft also pushed out Aurora 1.5. They extended their Earth system applications by adding 22 new variables and increasing it to hourly temporal resolution.
Which is incredibly granular.
Yeah, this means we are getting highly accurate, localized, probabilistic ensemble forecasting. And because of the hardware efficiencies we talked about earlier, you can run these complex meteorological models without needing access to a massive national supercomputer.
Exactly. And in the physical realm, the robotics advancements are accelerating just as fast. DeepMind introduced Gemini Robotics ER2.
Okay, what does that do?
This brings whole-body intelligence to robots. It vastly improves their real-time video understanding, task orchestration, and even complex multi-robot collaboration.
And Meta is doing incredible work here as well. They partnered with the University of Pittsburgh on assistive robotics.
Right.
They are taking models like Segment Anything and integrating them into robotic systems to help navigate complex, unstructured home environments. They're building systems to physically assist individuals with mobility challenges in spaces that aren't perfectly mapped out.
Yeah, and Meta is also pushing the absolute boundaries of brain-computer interfaces.
Oh, this one is crazy.
Yeah, their Brain2Pretty research offers a non-invasive path from brainwaves to generated words.
So no surgery.
No surgery. It uses an EEG cap to read neural signals and translates them into text, completely avoiding the need for surgical implants.
Which brings up a major warning highlighted in the Stanford AI Index 2026 report. We are looking at autonomous scientific research, zero-shot mathematical breakthroughs, and robots that can literally decode human brainwaves.
Yeah.
The Stanford report clearly states that while technical capabilities and global integration are accelerating rapidly, the frameworks needed to govern and evaluate these models are falling dangerously behind. The engineering velocity has vastly outpaced the regulatory velocity.
And that is the defining tension of our industry right now. We are building engines faster than we are building brakes.
We have covered a massive journey today. We started with hardware disaggregation and edge-native mixture of experts models. We looked at the geopolitical shift in custom silicon, the evolution of long-term memory frameworks, and how models are solving the Riemann hypothesis and forecasting cyclones.
The sheer breadth of the innovation is staggering. But, if we connect all of this back to you, the data scientist navigating this landscape, it provokes a very specific realization about where our profession is heading.
Leave us with a final thought on that. What does this massive shift mean for the listener?
Well, think about the combination of skill opt, allowing agents to evolve their own skills, and Anthropic's models developing internal mental workspaces. The job of a data scientist is fundamentally changing. You are no longer just optimizing a static mathematical function. You are managing an evolving digital workforce that thinks before it speaks.
Yeah.
But here is the provocative implication that nobody's talking about yet. Liability and intellectual property.
Oh.
Right. If an autonomous agent with its own mental workspace and self-evolved skills discovers a new scientific method or a novel mathematical proof, who owns that intellectual property?
That's a great question.
And conversely, if that same autonomous agent makes a catastrophic error in a production environment, who is legally liable? We might be rapidly approaching an era where data scientists need AI liability insurance, and where the legal definition of a creator has to be completely rewritten. In this new paradigm, your ultimate skill isn't just going to be writing Python code. It's going to be behavioral management and navigating the legal boundaries of autonomous thought.
We used to write code expecting absolute line-by-line determinism. Now you are managing black boxes with internal thoughts and self-evolving skills. The X-ray machine is broken, and the models are thinking for themselves. Thank you for joining us on this deep dive.